Now we will see the sequence network for a transformer. So for a transformer, there is various kinds of configurations possible, right? You can have a star star transformer, delta delta transformer, delta Y and Y delta, and in addition the star can be grounded or it may not be grounded. Okay, so positive and negative sequence networks, there is not much problem here, but zero sequence network, it is going to be a little more complex. So the positive and negative sequence network, this is simply going to consist of one impedance. Okay, so it can be Z1, which is the positive sequence impedance, same as the negative sequence impedance. Both of them, they are equal. Okay, so now we will see the zero sequence networks. Now the first point is, for an ideal transformer, the current will flow in the primary only when there is a current in the secondary. Okay, only when secondary current flows, primary current will also flow. Okay, so this is for an ideal transformer. In a practical transformer, the no load current will come into picture. Okay, now the second point is, zero sequence currents can flow in grounded star connection only. Grounded star connection, because the ground will provide a return path for the zero sequence currents. What happens in positive and negative sequence? These are three-phase balanced systems in a conventional sense, right? So if you add all of these currents, then they will be zero. But if you take zero sequence currents and if you add them, they are not going to cancel each other out. There needs to be a return path. Okay, so when there is a ground connection, then a return path is available. Okay, so ground provides a return path. Now what about the delta winding? In delta winding, if you consider the line currents, so let us say this is a delta connection, right? Now what are line currents? Here, whichever currents are flowing in the line, this is the line current, and if it flows through each of the phase, that will be the phase current. So in the line currents, there is not going to be any zero sequence component because there is no return path, there is no neutral. Okay, but the zero sequence components can flow in the phase. Why? Because there is a circulating path, they can circulate here. Okay, so in delta winding, zero sequence currents cannot flow in the line, but they can flow in the phase or the legs of delta because of availability of circulating path. Okay, so here we will make use of a simple circuit, so we can very easily draw the zero sequence networks for each of the type of connections, right, for the transformer. So this here is the zero sequence impedance. Now these switches we will name as, this we will name as S1, okay, and this we will name as S2. These are the series switches, and here you have switch S3, and this we will take as S4. So now S1 and S3, they pertain to the primary side, while S2 and S4, they pertain to the secondary side. Okay. Now this S1 switch, it will be closed if it is a Y connection, Y configured transformer, and the neutral is grounded. Okay. Otherwise S1 is going to be open, and S3 is going to be closed if it is a delta connected winding on the primary side. Okay. Similarly S2, if the secondary side is Y, that is star connected, and the neutral is connected to ground, then S2 will be closed. Okay. and S4 is going to be closed if the secondary side is delta. Okay. So we will go one by one, it will become more clear to you. Case 1, we will take star star connected transformer, both sides are grounded. Okay. So what will this be? Here S1 and S2 both are going to be closed. Okay. So here we have star grounded, and the other side also we have star which is grounded. So the circuit, the zero sequence network, it is going to be, this is S1, this is the zero sequence impedance, and S2 is also closed. S3 and S4 will be open. Okay. Next we will consider another case. Case 2 is when star star but only one side is grounded. Okay. So it is, let us say we will take the primary side to be grounded and the other side is not grounded. Okay. So here S1 is going to be closed and S2 is going to be open. S3 and S4 are also open. Okay. Next, case 3 is both are star but both sides ungrounded. So here no switch is going to be closed, right? All of the switches are going to be open. Next we will consider delta case. Let us say both are delta delta. Then here you can draw like this, right? Delta delta. Now what is going to happen? Here S3 and S4 are going to be closed. S1 and S2, they are going to be open. This is S3 and this is S4. Okay. Next we will consider the case of a star and delta, and let us take the star to be grounded. Grounded star. So here what is going to happen? This is going to be grounded while this is delta. So here S1 is going to be closed because it is the primary side, star is grounded. Z0, here the switch is going to be open. And here this switch is open, this switch is going to be closed. Okay. So this is the zero sequence network. Next you can take the star delta where the star is not grounded. Okay. So this is going to be like this. Now here S1 is going to be open and here S4 is going to be closed because on the secondary side you have delta. Okay. Every other switch is open. Okay. So this is for the star and delta which is ungrounded. Star is ungrounded. So in this manner, using this switch circuit, 4 switches and the impedance, you can draw the zero sequence network for any configuration of the transformer. Okay.